Let me go right into sharing screen and clean this up. So we've been talking about the UI system, and I pointed you to these different web resources. The three components I will speak about are the button, the slider, and the text. But as I showed you with the examples, there's more you can do with these things, various stuff. We have to use scripts with these, and any script that requires access to the UI must have the using Unity engine.ui included up at the top of the script. And we were talking about the canvas. And anytime you create a UI element, like a button or a panel, it'll automatically make a canvas and make that object the child of a canvas. If you already have a canvas in there and you create an element, it'll be added to that canvas. You can have multiple canvases in a scene as well. We looked at the three different options for the canvas. The overlay, which is the one that I'll deal with mostly, where it's just on the screen. We also had the camera, where the UI was an element that was placed out in front of a specific camera. And we also had the world space, where we could put the UI in a particular place. And often we do this by putting the canvas as a child of a particular object, and then its relationship to that object stays fixed as we move the object around. This is often used with the little health bars that are above enemies or our character. We can have that UI that moves with the character. So we were playing with a button. We made a scene where we had some buttons, and we were talking about the Rect Transform and how that's used to position our objects within the scene. So for instance, here with this canvas, I have a panel, and it has a rect that is putting it at a position and has a width and a height. And we can adjust all of these things in here in the inspector, but it's often easier to select this fifth one here, the rect tool, in which case we can now kind of drag things around and move things where we want it to be on the screen. And you notice all of that stuff adjusts automatically as we were doing that. We had gotten to the anchors, and the anchors are tricky. The anchors are these little triangles down here at the bottom. And you can read about how it computes the position of the UI element as a function of the anchors. But in many ways, it's easier to just use the presets that come here with our Rect Transform inspector. And here I've selected to have the anchors at the lower left-hand corner. And that means that this will stay the same size. It'll never scale. If the anchors are not set next to each other, if the anchors are like this, then the object will scale. But having them all together means that this is a fixed size and a fixed position relative to the anchor. And also watch these numbers here as I change this now to the upper right corner. Those numbers all changed because the position is relative to the anchors. And this one I would want to have probably up in this corner to have it match up. No. I also talked about the idea of having a panel in which our UI elements are maintained. So I have this panel, and inside it I have the various buttons, and I can position them within this manually, or I can use one of the layout groups. So I've added to this panel a vertical layout group. These are available here from component, layout, and we have vertical, horizontal, and grid layout groups. And I've picked vertical here. And the nice thing about this is if you check the width and height here, it automatically scales these things to fill our UI. If I expand it, the buttons all scale. If I expand it this way, the buttons all scale. And I have these paddings around the thing. I can put 20 in between the buttons, and it spaces them all exactly the way we want to. Now, if you're not happy with this, you can always turn off the scaling, and then each of these elements are now movable on their own, and you can adjust them. But of course, if I turn that panel back on again, it will put them back in the position that it thinks is correct. So definitely the vertical layout group is a handy thing to use to lay out our elements within one of these panels. Horizontal works kind of the same way. It lays them out horizontally, and grid's a little trickier. You have to specify how wide you want your grid to be and so forth. Now, when we get to scripting here, there are two basic modes that our UI elements will operate in. One is interactable, and the other is not interactable. And our buttons here have a check mark here for interactable. Buttons in general will be interactable because we want to be able to press them while we're playing the game. But on the other hand, sliders might be non-interactable in the sense that we want to control what's shown on the slider from the script. We can also set sliders to be interactable, in which case these are the ones that we can slide back and forth in the game and change various settings of what's going on in different scripts. So it's key here that we have this interactable setting. There are other settings that we can play with here. With a button, we can have its different colors. We have the normal color, which I'll make green. We have the highlighted color, which I'll make kind of red. And we have the pressed color, which I'll leave alone at gray. And we have a selected color, which I'll make magenta just to have something happen here. And so now as we interact with this button, it's ordinarily just green, but if I interact with it, it's highlighted. If I press it, it goes to that gray, and if it has been pressed, it's now magenta. So all of these colors can be adjusted here in the buttons inspector. There's some other stuff that we won't bother with. So we need scripts. And a handy way to keep things organized is to have an empty game object that's somewhere in our game. It's not a visible entity. It doesn't have a mesh render or anything. It just has a transform. but we put our scripts on it, and we can then access them from our different UI elements. You can do this with the script container, or you can put the scripts on the canvas, or on the panel, or on the buttons, or on your player. You can put this script container wherever you want. But I believe in the examples that I'll show here, I'm going to put them, I'll save that. I'll put them on this empty game object here, which apparently I have got a mesh renderer and so forth for it. But it's down here. Here's my function container version 1 script. Now, I'll show you quickly what this program's going to do. What this program's going to do is it's going to sit here with its button that says press to start. It has a slider that's going to keep track of the count. And when I press to start, the count runs until it gets to some level, and then it stops. And I can repeat this and stop it at various points here. So I have this element that I'm controlling something that's happening in a script. So our script, function container, and in my version it's called V1, we have this Unity engine.ui. This is necessary to be able to define sliders and text objects that we're going to access within the script. And I have a public variable for the counter and a public Boolean for the counting. And all of these have little presets. These don't. None of these are necessary from the inspector. They're not something that we would set in the inspector, but as you're writing code, making them public means that I can see them. I can see these things. And if you watch that little counting as this thing plays, counting is false, counter is 0. As I play here, counter goes up, and when it's playing, counting is true. So often in the debugging stage, we can make these variables public so that we can see them in the inspector. Now, when you make a new script, it comes up with the kind of default usings. It comes up with a start function that's empty and an update function that's empty. What I'm putting in the start function, which, as it sounds, happens when the object starts, I'm going to use a GameObjectFind function to find the test slider that's in my game somewhere. So here in the panel is an object called test slider. And this is going to find that object. Now, I don't actually want the object. What I want is the component on that object, the slider component that's on that object. If we look at the slider here, it has a component called a slider. And so GameObjectFind test slider finds the object, and getComponent slider accesses the component on that object, which I'm storing in this variable mySlider, which is of type slider. I'm doing the same thing for test text, the other object here, and I'm finding that object, and I'm accessing the text component of that object. So we're reaching out into the world, finding objects by name, and the name and case all has to be accurately identical. And I find those different objects. Now, I've got another little scene here well, let me go on. Let me just quickly switch to this other scene, the version 2 scene. And in the version 2 scene, it looks identical, but there's one slight difference. I'm using, let me get V2. In this one, I'm using the function container V2, which doesn't have these find statements in it. And so this looks exactly the same here. My function container has the counter, the counting, my slider, and my text. Now, without the find statements, watch what happens in the console. I get null references, lots of them. And let me stop this and restart this again, and let me turn on the error pause. Now, whenever it throws one of these red errors, the program's going to stop. And so when I run this now, the program will stop. The pause button came on here. The program has stopped, and it's telling me where that error is. This is critical. You're going to be running into errors all the time, and null references are a fairly common one. If we read what this says, it says null reference exception, object not set to an instance of an object, and it tells me where it is. It's in the function container V2, and it's at line 17. And if I double click on this, it will leisurely open my Visual Studio and take me to the offending line in that script, line 17. Takes a while to open. Should have started that to begin with. I want function container V2. So here's the offending line, line 17. It's telling me it's happened in line 17 here. So line 17 is where it's accessing my text and trying to set the text value. You notice I turned off the my slider find game object finds here, and that's why it's offending here. And the solution to this is to manually drop things in the function container. So I've got my panel here and my function container, and I can drag manually this slider object here and this test text object here. Whoops, gotta grab it. And put this here. And now this is going to run just fine and behave exactly the same way the other one did. It's even though I have that console with the null start, let me start it. Everything else functions appropriately, and I can press the start button and it counts. And when it gets around to 100, it stops. So subtle distinctions there. You can find the objects with the game object find and their name and access the component, or you can put them in manually yourself. So what's the rest of this do? Well, here's the update function. The update function happens every frame of the game. Every time the game finishes rendering a scene and is ready to display it to the screen, which happens about at least 60 times a second. That's our frame rate. What this is going to do is set the text of the my text object, the script. That's basically this box right here, where it says count equal, it's putting in that the string count blank equal blank concatenated with the value of the counter converted to a string. Text values have to be strings. They can't be integers or floats or anything like that. And Unity has a method that converts any data type, vectors, Booleans, integers, floats. It converts them to strings, and we can concatenate the plus. We concatenate to the count. It also sets the value of the slider to the counter. And that's what's moving this, the little button along the slider is it setting the value of the slider. Now, the slider has a minimum and a maximum value and a default value. And we can set this value. I can set it to some other value and it will change. And we also can constrain it to only show whole numbers. I haven't bothered with that. Counter is an integer, so it's going to be a whole number anyway. Now, the rest of this is a little if statement. If it's counting, counting is that Boolean up here, which is initially set to be false. So if counting is true, it'll increment the counter. Counter plus plus makes it, increments it by 1. And here's a little test. If that counter ever gets greater than 100, I'm going to set counting to false and reset the counter back to 0 again. So that's what's going on here when this thing runs. Right now, if I look at my function container, counting is false. When I press start, counting turns to true and it counts. And it counts, and when it gets to 100, it sets counting back to false and stops. Now there's one other little piece of this, and that's how the button accesses the script. And I haven't shown that yet, but that's done with this public function. This is part of the function container script, and it's a public function. Public means it can be called from another script, from some other object. And we're going to call it from the button by adding an on-click event to the button. Let me get back in V1 here just so that we have it. So in V1 here, in the panel, in the button, first of all, the button is interactable. It's got all these different color settings so that it does the different stuff. And down here, I have added, by clicking on this little plus, an on-click event. And the on-click event needs to have an object that contains the script that we want to access. So that's this function container. And you can drag and drop objects into it, or you can find them by looking through the scene or looking in the assets. And the function that I want to call is in the function container v1. And you can see there's a lot of stuff that we can access here from an on-click. We can do things like turn on and off the game object. We can move its transform and do all kinds of stuff. But basically what I want to do is access the function container v1 script. And there's stuff that I can do in here. But what I want to do is call that public function toggle counting. And so that's going to call this function, which does nothing but reverse the truthness of counting. Counting is equal to not counting. So if it's true, it turns it to false. If it's false, it turns it to true. And that's all we have to do. this little public function is going to toggle that counting on and off, and it runs. So that's all pretty cool. We have a little game here that counts for us. I'm going to stop sharing here and entertain any questions. Let's see, is there anything in chat? For the find object function, can it only find prefabs? No, it finds objects that are in your scene by name. And one thing that's a little tricky is if there is more than one object with the same name, which is possible, you don't know which one it will find. It will find one of them, but you don't know which one. Any other questions? Okay, so back to sharing. So let me show you another example here that's kind of fun. The color cube here. So in this case, I am going to be able to interact with the sliders. The sliders are going to control the color of my little cube here. So right now, all three colors are fully saturated. So I have a white cube. If I turn the red off, now I have green and blue, and so I have a cyan cube. And I can move that slider around and adjust the color of my object with the slider. I've always been interested that red and green make yellow. It's so non-intuitive. So how do we do this one? Well, again, with the script. We've set up the canvas with a panel. I believe I have it tied to the center. I've picked this one so that my anchors are all here in the center. That means my object will stay positioned relative to that. It won't move to the left or the right, and it will not scale because the anchors are all together. I think in the panel here, I initially used a grid layout group. So with my grid layout group, which I have turned off, watch what happens when I turn it back on again. When I turn this on, that didn't happen. When I turn this on, the objects now, because in a grid layout group, you're specifying the width 300 and the height 60 of these objects. When I turn that on, my text is the same size as my slider, 300, and that's too big for my little window. My text is going to stick out of the panel. But this also kind of set it up in a nice checkerboard. And I think what I did here was, after setting it like this, I then turned off the grid layout group and I went back in and manually closed my little text objects up so that they just nicely filled the panel. So getting things to look the way you want them to involves fiddling, and anchors are definitely the hardest thing to play with. So in this change color script, I have a private variable for the mesh renderer. The mesh renderer is on the cube. I believe this script, the color changing script, is on the cube. Here's the change color script on the cube. I also have the rotate script, which is what's spinning it around. And I'm going to access that mesh renderer in order to change its color. I have public red slider, red text, green slider, green text, blue slider, and blue text. And all of these are assigned manually. I could find them by name, but I'm not bothering to do that. They're all assigned manually. in that cube, I've dragged and dropped the red slider, the red text, the green slider. I've manually inserted them there. So in Start, what I'm going to do is access the mesh renderer using a get component. Now, because this script is on the cube, all I need to say is get component mesh renderer, and it will find that mesh renderer that's on the object that the script is on, i.e. the cube. I then want to access the color. So I have to kind of drill down into what the mesh renderer has. The mesh renderer has a material, and that material has a color. If I look at my cube, the mesh renderer has one material. It's the default material, and I'm going to change the color of that default material. We could have a checkerboard on there or any other kind of material. So I've accessed the mesh renderer's materials color into a color variable, C. Color variables have red, green, and blue channels. They also have an alpha channel, but I'm not playing with that. But we have a red, green, and blue channel. C.R, C.G, and C.B are the red, green, and blue channels of that color. And I'm just setting each of those channels to the value of the slider. So that's interacting with the value of the slider that's on the screen. If I set this, if I restart this here, and I go into my red slider, and I set its value down to the 0.19, in this start, it's going to initialize my cube with a kind of cyan color as it reads that 0.19 out of the value. Let me set that back up to 1. So having set that C color to the slider values, I'm now going to store that back into the mesh renderer's material color. Sometimes, I think this was true in older versions of Unity, like Unity 2.17, you could actually access the mesh renderers.material.color.r and change it directly. But in 2.18, 2.19, they changed that so that you now have to make a copy of it, change it, and then reassign it back to the color. This is true of a number of Unity structs, such as transform position and others and rotation and some other stuff. So having assigned that color back to our material, I also now want to update the texts that show next to my two little sliders. And so I set red text.text to be that C.R. and I've got to convert it to a string. And the little F2 in here, it says 2 places to the right of the decimal. If you left that out, it would display the whole number, which would have 8 different places. And so we've set that back. So that's what happens when we start. It reads the values of the slider and sets the colors of the cube and sets the value of the texts that are showing there in my little panel. Now, what happens in the update function? Well, the update function, there is no update function. I'm sorry, there is no update function. There's only a public function, set color. And this public function is going to be called by a slider whenever a slider changes. And it does exactly what the start function does. It accesses the material's color, changes its value to the setting of the sliders, changes the color, stores that changed color back into the material's color, and sets the text. So that's exactly the same, but this is a public function callable by other scripts. And on each of the sliders, I've added an on value changed. And so whenever I change the value of this interactable slider, that's going to access the object that has the script on it, and it's going to access the change color function, change color method, and that public set color function that's down inside it. And you see there are a lot of other things that we can access from the on value changed. I could change the rotation rate of my object if that script had a public function in it. So that's all pretty cool. We have this tool now where we can interactively play with the color settings of our little cube here and make it into different color objects and investigate what the RGB color space looks like as we change those color saturation values from 0 to 1. So I'll stop sharing there and entertain questions. Any questions? Everyone's numb from that, right? Anything in chat? Nothing in chat. All right, well, let me continue on here. Let me close this one. Don't say it. So that's the UI. Now, our goal here, of course, is to put this in our game. And in our game, let me get the game started here. It's this one. So in our game, we're going to use buttons to select scenes. At some point, we're going to have a game that has more than one level or scene. We might have a day scene and we might have a night scene. We're going to use sliders to indicate our level of health and points that we've picked up. And of course, the slider is also going to have a text value that reads out those values as well. Ultimately, in the game, we're going to do something with those win and lose functions, the little functions that right now do nothing but print a little debug message in the console. We'll do something with those functions where we'll load scenes that we transition to when we've run out of health or when we've achieved enough points to have won. And so we're going to get the points and the health working here. So we'll work on the health and points UI. So here's our little scene. This is the begin scene where we haven't got any UI elements. And here's the scene where I've added UI elements. Our script, of course, is going to need the Unity engine.ui because we're going to be accessing sliders and texts. We won't get the buttons until we start changing scenes. And so in my canvas here, which is in screen space overlay, because that's the easy one to do, I have a panel, and within the panel, I have point slider, point text, health slider, and health text. and I believe I actually laid these out all manually. There's a scene here as well where I use the grid layout group to lay them out. So here's the grid layout group that lays them out. It looks a little different manually. I was able to make the sliders kind of skinnier and the text maybe a little bigger. So I've got, so this is a script that I believe is on the canvas. It's my HUD new UI script, and it has sliders and text. Here's my little debug function that I won't show in the script, but that just prints debug information. And I have public variables here for the sliders and texts. Because I'm going to find them, I wouldn't need them to be public, but it's nice to be able to see what we've got here. And I have a private player status script that I'm going to access and find my player. So in Awake, and Awake is kind of like the start, except it runs before start. There's Awake that runs first, and then start that runs later. We'll talk more about the details of Awake and start later. But here, I'm going to use a find object of type, player status. So this is going to go out into the world and find a script named player status on whatever object it's on. So it's going to locate our player for us, our FPS controller here that has a player status script. It's going to find that instance of it. And then I go through and find points text, health text, point slider, and health slider by name, accessing the text and slider components of each of those objects. Game object find finds a game object, and get component gets the component that's on that object that we've found. So that happens in Awake. Now, the update function is fairly simple. I don't know if you remember, but back when we were doing player status, we wrote two public functions, get points and get health. And each of these just returned the current value of points and health that our player status had. So I'm setting the point text with a label, points equal. It's going to put a label up in here. Concatenated, the plus operator concatenates two strings together. And here I'm accessing that public function in the player status script, get points, and I'm converting it to a string. I'm doing the same thing with health. Health text is got the label health equal. It's concatenated to the player status public function get health, converted to a string. And I'm also setting the slider values as well. And I'm doing kind of redundant calls to get health and get text. I could do this more efficiently. With the text items, if you want labels, you've got to include them yourself. And we have to always remember to convert integer, floats, bools, any non-string type variable to a string with the toString function. So I have to have a canvas in our scene. The canvas has a child panel. I've got the reference text and slider items. All the names have to be appropriate because we're going to find them in the awake function. And now when I play the game and I run into this rolling bomb, if I can run into the rolling bomb, I've lost 25 points, and it shows in my slider when I go up here and run through the damage wall, I lose another 25. And when I pick up these pickups, I get 50 points. And now I have 100 points. And I think there should be a little console message that said you won. I don't see it, but it should be there. And there's one more bomb up here that I can lose some points. And somewhere down here, I can lose more points. And I believe in the console, I didn't see that. I don't know where they went. Oh, here they are. I had them turned off so they didn't show, but there's where I won and there's where I died. You can turn off debug messages, debug warnings, and debug errors. So we now have a UI, a heads-up display, a HUD, whatever you want to call it, and it displays the status of my player while we're running, and it's all done with communication among scripts. The HUD script is communicating with the player script, calling functions on it. So pretty cool. Any questions? I'm going to stop at this point and entertain questions. Anything in chat? No. Next time we'll add transitions to win-lose scenes, and we'll glitz this thing up with explosions, other kinds of fun stuff. I will stop recording at this point.